Welcome to Calculus for Dogs. Calculus made so easy a dog could do it. Today, we'll be learning how to do a simple accumulation problem using dog food as an example. So, what is an accumulation problem? An accumulation problem is one in which you're trying to figure out how much something has accumulated at any given time based on a given rate of change. In math terms, that means that big F of x is equal to the integral of f of x with respect to time between the starting time and time x. Since an integral is the opposite of a derivative, we can also conclude that little f of x is the derivative of big F of x. Some important things to consider when thinking about an accumulation problem are questions like when does big F of x reach a minimum or maximum, or also what does big F prime of 2 represent, and what does that actually mean? So we'll be covering these later on in this lesson. Now, I'll start the experiment. I'm serving the dog 8 plates of food, the first one containing 15 pieces of food, and each one containing 2 fewer than the last until the last one, which only contains 1. As the dog's eating the food as I serve it, we can model the rate of change in how much dog food is on the porch by the rate at which I'm adding it minus the rate at which she eats it. Since I started off putting on more food than the dog could eat and transitioned to putting on less than the dog could eat, we know that at some point when it switches from more to less than the dog can eat, there will be an absolute maximum of food on the porch. To figure out where the absolute maximum of food on the porch was, we'll calculate the average consumption per second over the first 50 seconds and do our calculations from that number. Since at the 50-second mark she's eaten all but 2 of the pieces of kibble, we'll take her rate as being 62 pieces every 50 seconds, or about 1.2 as we'll use in future calculations. Graphs like these should be familiar to you if you've worked with derivatives before, so this is really no different than working with any other type of derivative, where in order to find the maximum accumulation of kibble, we'll have to find the point where the amount added is equal to the amount lost, and we'll have a switch from positive rate of change to negative rate of change. In order to find the point where the rate of change is equal to 0, we first make an equation for the amount added and then set that equal to the amount subtracted by eating, and in the end we come up with the rate of change being 0 at time equals 22.5. Now, in order to find the maximum value of the amount of kibble, or rather how much kibble there was at time 22.5, we must first take the antiderivative of the equation for the rate of change, and then evaluate that between time 0 and 22.5, and what we end up with is about 20 pieces of kibble at the maximum time. And lastly, we have some inferences that we should be able to draw from the data we've collected, such as what is f prime of 10, and fairly simply we can just calculate what the value of that is, but more importantly it's good to understand that the derivative of the amount is a number of pieces per second, and that for the second problem, the second derivative of that will be the number of pieces per second, or rather the change in the rate. Thanks for watching. This has been Calculus for Dogs, and I hope you learned something new.